Okay, I'm back. I accidentally cut off the first video after the first three questions. So let's go right into question number 4. Okay, so here we are. Question number 4. Now it says solve by making, it says hundreds, tens, and ones chart and drawing place value discs. But we have gone over in class and we've told them you can solve it using any method that you feel comfortable with. Okay, so if we're doing division here, most of us are going to feel comfortable using long division. All right, so actually, I think that is the method that we want them and which we have gone over in class. So, using long division, here we go. So it's 539 divided by 3. All right. I have my dirty monkeys smell bad as my divide, multiply, subtract, and bring down reminder. Okay. So I have 3. Can 3 go into 5? How many times? Yes, 3 can go into 5 one time. 3 times 1 is 3. 5 minus 3 is 2. Bring down the next number. I'm going to bring down my 3. I now have 23. Can 3 go into 23? Yep. 7 times without going over. 3 times 7, 21. Subtract. We divided, we multiplied, subtracted. Still have a number to bring down, which is 9. Can 3 go into 29? Yep. 9 times. 3 times 9, 27. Subtract that, you get 2. Nothing left to bring down, so you're left with remainder 2. 179, remainder 2. Okay. And now you'll see there's just 2 more long division problems, same strategy. Okay, so, and remember, at any point you could pause the video. You pause the video, hopefully you've got a piece of paper or you're looking at your review sheet that we went over in class. And you can go fast forward, rewind, whatever you have to do to help you with the problem, okay? Because you will see just like this tomorrow. So we have 628 divided by 3. So 628 divided by 3. Divide, multiply, subtract, bring down. Can 3 go into 6? It can. 2 times. 3 times 2 is 6. Subtract. Bring down the 2. Now, when you get to this 2, you're starting over again. I brought down. So you're starting over again with dividing. So can 3 go into 2? Which would be 2 divided by 3. Can 3 go into 2? No, it can't. So since it can't, you're going to put a 0. All right? Now I don't have to do 3 times 0 is 0, bring down the 0, subtract 0. I could just leave it at 0 and now say, okay, let me bring down the 8. Can 3 go into 8? 3 can go into 8 9 times. 3 times 9 is 27. Now you subtract and you get 1. So you have 209, remainder 1. And that was for number 5. Okay. All right, I'm going to erase. And we're going to go to number 6. Number 6, 2100 divided by 7, using any strategy that you can. So 2100 divided by 7, which you see here. You should notice right away we've got some friendly numbers. We've got 21 divided by 7. Well, 21 divided by 7, they're friendly numbers because 7 can go into 21. 7, 14, 21. it can go into it 3 times. So you should be able to see that 21 divided by 7 is 3. And then we have to take our 2 zeros, 2 powers of 10, and bring it right over. And now we have 2100 divided by 7 equals 300, right? And your check here would be 7 times 3 is 21, and bring our 2 zeros, 2100. So your answer is 300. With one like this, with zeros, you don't have to do long division. You can, and you would still get the same answer. But this, when you got some friendly numbers, you should be able to do it without long division. Okay, let's move to number 7. Okay, you're going to see here, I'm going to make this a little bit smaller so I have more room to do work. I'm going to look any strategy. So to start off, we've got 4,316 divided by 4. 4,316 divided by 4. I'm just going to go through, for the sake of time here, I'm just going to go through my long division. And if you need to, like I said, pause it, rewatch it, and you'll see it's very repetitive. It's the exact same steps for every long division problem that you're going to get. So I start here and say, can 4 go into 4? Well, 4 can go into 4 one time. So now you know your answer is going to be in the thousands place. So you're going to have 4 digits. We went over this today in class. 4 digits in your answer, so it's going to be in the thousands. 4 times 1 is 4. Subtract, get 0. Bring down the 3. Can 4 go into 3? It can't go into 3, so I put a 0. Now I have to bring down the 1. Now it's 4 into 31. How many times can 4 go into 31 without going over? Well, 4 times 7 is 28. 4 times 8 is 32. So 4 times 8 is too much. So 4 times 7 is 28. Subtract. You get 3. Bring down the 6. Start over again. 4. Can 4 go into 36? It can. 9 times. You'll notice how each time this 4, your divisor on the outside is going to be your divisor throughout the entire problem. All right? So you have 1,079. Next one, 5,308 divided by 5. 5,308 divided by 5. All right? Can you tell if this is going to go into it evenly or with the remainder? Well, we went over today, what we've been going over for weeks. Anything divisible by 5 is going to have to end in a 5 or a 0. This problem ends in an 8. When you count by 5s, it's going to end in a 5 or a 0. So this, you know, is going to have a remainder. So 5 goes into 5, or can 5 go into 5? One time. Let me change that color. 5 goes into 5 one time. 5 times 1 is 5. Subtract, you get 0. Bring down the 3. Can 5 go into 3? Can't go into 3. So 0 times. Bring down this 0. Can 5 go into 30? Yes, it can. 6 times. 5 times 6 is 30. 0. Bring down the 8. Can 5 go into 8? One time. 5 times 1 is 5. Subtract 3. Nothing left to bring down. Remainder 3. 1,061. Remainder 3. Good. So 1,061. Remainder 3. All right, won't use that color again. Now you go down here, we have the 2 multiplication problems. All right. Now, for all of these, you're going to have to show a check. All right. So, for example, here, if you're going to show a check that your quotient was 1,061, remainder 3. I'm going to do 1,061 times it by 5. 5 times 1 is 5. 5 times 6 is 30. 5 times 0 is 0. Plus 3 is 3. 5 times 1 is 5. Our remainder was 3. Add 3, 8. 5,308. And it matches up to your dividend. That's your check. And that's all you have to do. Okay? It is a lot of computations. This unit was a lot of computing, multiplication, and division. Okay? So now, this is what I was getting to before. Now you'll have your multiplication. Okay? So 28 times 54. You could choose. You could do either method. You could either do standard algorithm, or you could show an area model. 20 plus 8, 50 plus 4. You choose whichever one you want. We're leaving that up to you, all right? If you show both ways, make sure they're both correct. And if you do both ways and one way is correct and you have differing answers, then you know you made a mistake somewhere. So that's a built-in check when you're doing when you're multiplying. So 28 times 54. 4 times 8 is 32. 4 times 2 is 8. Plus 3 is 11. Placeholder, done with the 3, done with the 4. 5 times 8 is 40. Put the 4, 0. 5 times 2 is 10. Plus 4 is 14. Add up. 1,512. Go over here. Area model. 20 times 50. Now watch. This is where we've been getting mistakes for years. And we had a bunch today. 50 times 20. 5 times 2 is 10. Then add the 2 zeros. So 50 times 20 is 1,000. It's not 100. It's not 10. It's 1,000. Then 50 times 8 is 400. 20 times 4 is 80. And 8 times 4 is 32. If you're unsure of what product goes inside the box, start in the box and then shoot to the top and shoot to the outside. 20 times 50. If you're in this box and you're unsure, shoot to the top, 8, shoot to the side, 4. 4 times 8. Okay. You could combine here. You're going to add all 4 of those products because I'm now done with that. All right? So you are going to do 1,000 plus 400 plus 80 plus 32. But a lot of you could see that 1,400. Let me combine it. 1,400, 80, and 32. 2, 11, 1,512. Okay? Okay. Now, bottom right box. Remember, you can go back and pause if I'm going too quick. All right? I don't want to make this video hit 20 over here, especially since we had the first part. All right? 19 times 43. Doesn't make a difference if you did 19 times 43 or if you did 43 times 19, because we know that's the commutative property of multiplication. You can multiply numbers in any order. All right? 3 times 9, 27. 3 times 1 is 3, plus 2 is 5. Placeholder. 4 times 9, 36. 4 times 1 is 4, plus 3 is 7. 7. 5 and 6 is 11. 817. I'm going to check it by doing area model. I make my window. 19 is 10 plus 9. 43 is 40 plus 3. Inside each area, each product, 40 times 10, 400. 10 times 3 is 30. 40 times 9 is 360. 3 times 9 is 27. Some of you may be able to see that the 400 plus 360 is 760, or if you can't, add up all four. All right, but I'm going to go 760 because I'm adding these two together. And then 30 and 27, I'm going to say is 57. So I'm combining my products, adding them together, and you get 817. You get the same thing. So there you go. So it's 817. Okay. All right, now we're up to the last few. Number 8, word problem. Your bedroom is 32 meters long and 29 meters wide. How many square meters of flooring do they need? Well, when it says how many square meters, you only get square meters, square units, when you're multiplying. So here you're finding the area, length and width. Just because we see length and width doesn't mean we're automatically doing area, because you could be finding the perimeter and you're just adding up your dimensions, okay? But when it says square meters, now that's the key that you're doing area. So you're doing 32 times 19. I never thought I would say it. I like area model. 30 and 2, 10 and 19. 30 times 10 is 300. 30 times 9 is 270. 10 times 2 is 20. 9 times 2 is 18. I'm done with my outside products. I'm going to combine 300 and 270. It's 570. 20 and 18 is 38. 8, 608 square meters. Okay? You can do the standard algorithm too. You'll get the exact same answer. Okay. All right. I thought there was another page. Last 3. All right. So, number 9. You have 27 short sleeve shirts in your closet. You have 12 times as many long sleeve shirts. How many more long sleeve shirts do you have than short sleeve shirts? How many more long sleeve shirts do you have than short sleeve shirts? We may have not done the second part on your review sheet in class. I'm just thinking. I know the bell was about to ring, so very important right here. Number 9. You have 27 short sleeve shirts. Okay? You have 12 times as many long sleeve shirts as short sleeve shirts. So if I have 27 short sleeve shirts and 12 times as many long sleeve shirts, let me find out how many long sleeve shirts we have. 2 times 7 is 14. 2 times 2 is 4, and 1 is 5. Placeholder. 1 times 7 is 7. 1 times 2 is 2. Add them up. 324 long sleeve shirts. They want to know how many more long sleeve shirts than short sleeve shirts. Now you have to subtract. I'm going to put the larger number on top. 324 minus 27. Can't do. No. Little regrouping. 14 minus 7 is 7. Minus 2 is 9. 2. 297 more long sleeve shirts. Okay. Number 10. Costco. Costco makes extra cookies. Extra cookies for the holidays. The baker made 8 batches of cookies. There were a total of 288 cookies. If there was the same number of cookies in each batch, How many cookies were in each batch? Well, we're making extra cookies for the holidays, okay? And the baker makes 8 batches of cookies, and there was a total of 288 cookies. Total of 288 cookies. And he's making 8 batches. So I got to divide that by 8. Same amount in each batch. Let's do it. 8 can't go into 2, but 8 can go into 28. 8 times 3 is 24. Subtract, get 4. Bring down the 8. Now 8 goes into 48 6 times. So your answer is 36 cookies in each batch. And the last question. If you are buying packs of Poppets for your birthday party, Poppets are being sold in packs of 8. You have a huge family, so there will be 112 people at the party. If you want to give each person 4 Poppets, how many packages will you need? So you have to stop and you need to really think about the information that's in the problem. So you're buying packs of Poppets for your birthday party, and they're being sold in packages of 8. So I have 112 people at the party. 112 people. I want to give each person 4 Poppets. So I'm going to times the 112 people by 4. 8. That's 448 Poppets. Okay? But they're sold in packs of 8. So if they're sold in packs of 8, I need to take 448, divide it by 8. 8 can't go into 4, but 8 can go into 44 5 times. 8 times 5 is 40. Subtract 4. Bring down the 8. 8 goes into 48 6 times with nothing left over. You will need 56 packages. Okay. Somehow, if you've watched both of these videos, you're about a half hour in, and you would be prepared for tomorrow, as long as each one of these questions is making sense to you. If you know the steps, to your long division, and you know the steps to a 2x2 multiplication problem, I do think you will be fine. So with that being said, good luck tomorrow, and hope this helped.